Very good afternoon to all. On behalf of Marathwada Mitra Mandal Institute of Technology, I, Mrs. Meghna Yashwante, welcome you all to 3 days faculty development program on research tools for data science. In the voyage of research, tools play important role for navigation and speeding up research activities. This FDP is arranged to throw some lights on some research tools for data science. I welcome you all, and now I request Dr. Umesh Mohuril sir, HOD of Engineering Science Department, to brief about and MMIT.
Hello everyone and welcome to this FDP. Myself, Dr. Umesh Mohoril, Head of the Department, Engineering Science. I just welcome you all on the behalf of MMIT, Marathwada Mitra Mandal Institute of Technology. Let me brief about our organization. Marathwada Mitra Mandal Pune. It is one of the organization in the Pune established in the year 1967. They celebrated Golden Jubilee in the year 2017, having 53 years of academic excellence. The vision is having trust, welfare of masses. The trust is having 4 campuses across Pune city. There are 17 institutions and overall 13,000 plus students are studying in the different courses offered by the universities. All campuses are accredited with A grade by NAC. In short about our institute, Marathwada Mitra Mandal Institute of Technology, Lohgaon, Pune. The institute was established in the year 2008. It is affiliated to Savitribai Phule, Pune University. Approved by AICTE, the institute is accredited with A grade by NAC. Overall, the institute is spread over the area of 14 acres and with a playground of 6 acres. The institute website is mmit.edu.in. We are having a Center of Invention, Innovation and Incubation, Make It Happen Center. And this is a joint collaboration between Science and Technology Park, SPPU, Savitribai Phule, Pune University, Tata Technologies, and Marathwada Mitra Mandal. So this center is established in the collaboration of these 3. And the total investment is around 25 crore. So this is in short, in brief about our trust and our institute. We are offering the courses in computer engineering, mechanical engineering, civil engineering, mechatronics, and artificial intelligence and data science. So this was a brief about our trust and organization. I again hand over to Mrs. Meghna Yashwanta Madam for carrying out this FDP to the further session.
Thank you, sir. Now I request Dr. R.V. Bhotake, sir, Principal of MMIT, to address the participants.
Good afternoon. Thank you, madam.
Audible?
Am I audible?
Yes, sir.
Okay. Good afternoon, everyone. Today's speaker, Dr. Rajesh Kulkarni, sir, and Dr. Sandeep, sir, Dr. Sesham Anand, sir, and all dear participants. I welcome you all for 3 days faculty development program on research tools for data science. This is organized by our Department of Engineering Science, Marathwada Mitra Mandal Institute of Technology, Lohgaon, Pune. The objective of this technical session or this faculty development programs are to train the teaching faculties of all disciplines to understand the concept of research tools for data science, which is a very important tool for the research, data science. And at the end of this faculty development program, participants will learn the concept of data types, then data visualization, and statistical modeling, linear regression, logistic regressions, classification and clustering with R basics, Python basics, and etc. So I request all participants to make this session as a very interactive sessions. so that all you will get the benefits of this one and you will learn these concepts. So thank you everyone. Thank you, madam.
Thank you, sir. Now we'll begin this session. I take this opportunity to introduce our today's speaker, Dr. Anand Sesham, sir. We are very privileged to have with you, sir. A short information about Dr. Sesham Anand, sir. His PhD currently working as a professor of computer science and engineering at Mautri Venkata Subbarao MVSR Engineering College. He did his MTech from NIT Warangal and MS from Australia and PhD from JNTUH. His specialization is in the area of machine learning and artificial intelligence. He has around 19 years of teaching experience and highly passionate about the teaching. He has 17 research publications. He has been teaching a number of subjects in the artificial intelligence, machine learning, programming languages like C, C++, Python, and he is being awarded as a Best Teacher Award. He has conducted many workshops. So we are privileged to have you, sir. And I hand over this session to you, sir.
Thank you, madam.
Thank you, sir.
So let me switch on my camera for a bit so that everybody can see me for a. First of all, I would like to sincerely thank the management of Marathwada Mitra Mandal's Institute of Technology, the principal of Marathwada Mitra Mandal's Institute of Technology, the organizers of this FDP, and all the staff members of your department for giving me this opportunity to talk on WEKA. So, a very good afternoon to all the participants. First of all, let me share my screen. I hope my screen is being seen by everybody. Yeah.
Yes, sir. Yes, sir. It's the same.
You're able to see, madam?
Yes, sir.
Yes, sir.
Okay, right. Done. So, let me, since I cannot see all of you, I will have to virtually talk with you. So, good afternoon all. Thanks for participating in this FDP. Now, before beginning, I would like to give a small request. There is one big assumption I'm going to make. Now, looking at the workshop participants' profiles, all of you are from basic sciences, statistics, maths, etc. So, you are highly knowledgeable in those areas.
Hello, sir.
So, you know all the terms. There might be people from other departments also. So, the basic assumptions I'm going to make is all of you are interested. Yes, sir? Yeah, all of you are interested in data science, right? And then you are trying to use data science as a tool in your respective research work. Okay? So, when I say respective research work, I am assuming that all of you will be using data, right? Because it is data science. Okay, so we will be using WEKA as a tool, right? So let me. Okay. So are my assumptions correct? Are my assumptions that all of you are going to enter into data science and use it as research in your respective fields, and that you are all going to are interested in learning this WEKA as a tool, right? So
Yes, sir.
Yeah. So can I assume that if not all, majority of you are new to WEKA? Can participants can switch? I think you can unmute yourself and then talk. Okay, let's make this two-way talk. Okay, so I will be talking less and we all together will be working on this tool, right? So can I assume all of you are now sitting on your laptop or a machine and all of you have internet? Can I assume?
Yes.
Yeah,
Yes,
I'm
sir.
going to assume that all of you have internet, right? So we will be following only hands-on, less of theory, more of working on this tool, right? So theory we can always learn from textbooks and internet. Let's try to utilize this time given to us in trying to learn WEKA, right? Now, this is the philosophy I am going to follow. Fine, keep it simple, stupid, and Occam's razor. So we will try to make things as simple as possible, right? And we'll try to use as many simple methods and algorithms as possible, using as less assumptions as possible to get our solutions, right? So this is our philosophy, right? So the plan of action for today, for the next approximately 2 hours will be this. We'll have a brief break in between. Okay, but then this is what I want to do. So for those of you who don't have WEKA on your systems, we will install WEKA, right? And then once we install WEKA, we will be working through WEKA's various components or parts. Okay, so we will try to briefly understand this following parts of WEKA. So the WEKA has 4 major parts: explorer, knowledge flow, experimenter, and workbench. Okay, so we will try to understand all these 4 very briefly, right? And then in each such part of WEKA, we will take 2 or 3 examples and try to learn them. Okay, then after learning all these parts of WEKA, fine, we will do a small hello world project. Okay, those of you who have done programming, you might understand what is a hello world, right? Hello world program will be the first program we write when we learn any language. Agreed? Just like that, in WEKA, we will do a small hello world kind of a project. Very simple, simplest possible project on WEKA on a very simple data set. Okay. So in order to do this project, we have to make sure we understand all the components of WEKA. Fine. Then once we do this small project, hopefully if we have time, we will simply open a real world data set. Okay. Apply clustering on the data set and try to see how to interpret results on the data set. Okay. Then I have looked at the literature and I have downloaded 1 or 2 journal papers which have used WEKA for their work. Okay, so we will try to open that paper, 1 or 2 such papers, try to understand, and we will try to do that. All of you will be trying to attempt such kind of work on WEKA. So lot of things to do today in as less possible. We have very less time and lot of things to do. Okay, are you all with me?
Yes, sir.
Yes,
All
sir.
of you are able to understand me, right?
Yes, sir.
The pace of my talk, the pace is also comfortable because I'm a bit fast in talking. So kindly indicate whether I need to slow down or not. Okay. So all of you have WEKA on your system, or shall we download? If you want to download, just go to Google. Yes, please. Just go to Google and simply
go ahead, sir.
type,
Go ahead.
yeah.
Go ahead. We are following you, sir.
Simply type WEKA download. Okay. Go to the main website. By the way, WEKA means Waikato Environment for Knowledge Analysis. Okay. So this is developed by University of Waikato, New Zealand, and it has its own web page. So this is the web
Oh,
page
sir.
you'll go to. All of you who don't have WEKA on your system, please go to this website. Okay, and then click on software, right, and then click on download. We will make sure we'll go through only the official website. Fine. Now you have to download. There are two things. One is a stable version, and one is a developer version. Okay. So developer version will be dynamic. As and when new programs are being added into WEKA, it will be uploaded. So you'll be downloading the latest version of WEKA always. Okay, but it's not stable. It's not guaranteed. So if you want to really use WEKA for your research work, you better download the stable version. Okay, so you will have to click and download the self-extracting executable. Self-extracting executable. Anybody who don't have WEKA, will you shall we stop for you to download, or shall we move ahead?
Go
Okay.
ahead.
Right. So let's go. So I will be assuming you have all downloaded the appropriate WEKA tool. So click on Start button and click on WEKA. Okay. This will be the window you will get. So let me remove this. Okay. This is the window we will get. So what is the full form of WEKA? WEKA Environment for Knowledge Analysis. Okay, and the version I am using is 3.9.5. You may have any other version, it doesn't matter for our work. Now, one point I would like to request is, when you are using WEKA for your research, remember the version in which you are working. Okay, so when it is because when you want to show your results on a different machine in a different WEKA version, the results may not be compatible. Okay, sometimes you may face a problem. So remember the version. Okay, right. So if you look at the screen, you will see 1, 2, 3, 4, 5. There are 5 components of WEKA. Okay, majority of the times we will be working on Explorer component. Okay, Explorer. Now, Explorer component is used for doing your actual data mining, your actual machine learning. Fine. It can be classification or it can be clustering. Fine. You all know classification is nothing but trying to predict unknown values of a particular attribute. Right? You're trying to predict. And that attribute which you are trying to predict, okay, WEKA calls it as class attribute, right? So that's about classification. So you can do classification and regression. Both are prediction methods you can do, and you can do clustering also. So just click on Explorer, you will get this window. Okay, this is called your Explorer window. Fine. So this is the place where you will be doing your actual majority of your work. Fine. Now let me close this. Let me click on, there is something called experimenter. People who are doing research on your data set and you would like to compare algorithms on your data set. Okay, so you want to do comparative analysis. Then you can do that in experimenter component. Okay, you just click on experimenter component, you will get your experimenter window. Fine. So this is where you will do your experiment. So we will try to do that. Right. Now the next will be knowledge flow component. Knowledge flow component. Okay, whatever you can do in Explorer component part, you can do that also in your knowledge flow. Okay. The only difference is that the metaphor changes. the metaphor of working changes. Whereas in Explorer, you will use menus and buttons. You will use a canvas here, and then you will be trying to paste your icons onto this canvas, connect to those icons, and then run the flow. Okay? And the one more difference between knowledge flow and Explorer is that in knowledge flow, you can do machine learning or data mining on sequential data. Okay, data which comes one by one. Okay, incremental data mining, that's what we call that. Okay, whereas we can't do that in Explorer, right? Otherwise, whatever you can do in Explorer, you can do here. That means you can do your supervised machine learning, you can do your unsupervised machine learning, okay, and you can watch your results in knowledge flow just like in Explorer, right? Now there is the fourth component called workbench. This has been recently introduced in recent versions of WEKA. You see, in your workbench, they have clubbed Explorer, they have clubbed the experimenter, right? And they have also clubbed the knowledge flow into one single component. So you can just use workbench to do all your mining work and all your comparison work here. Fine. So that's your workbench. The last component is a command line interface. For majority of us, we don't need this command line interface. Okay. Right. If you are wanting to work on command line interface, I suggest you go for Python rather than working on the CLI. Okay. So that's about the various components or parts of your WEKA. Fine. So before going to that, let me give a small clarification. Now, you might be seeing these words data science, and then you will see data analytics, fine, and then you might have seen this word data mining, right? So if you see, the scope increases as we go up from data mining. Okay, so from data mining, data analytics came. So data analytics covers entire data mining with something extra. Data science covers entire data analytics with something extra. Fine. So usually all these terms are vague and they're all used as synonyms. Fine. But for data science, usually we will be working with either social media or big data, right? Or new AI. Fine. So advanced stuff we will be doing in data science. When you come to data analytics, we have descriptive. So there is a reason why we are studying these terms. Okay, if we're doing that, we have descriptive data analytics, then we have predictive data analytics, and then we have prescriptive data analytics. Okay. Now you see, these two we can do in WEKA. Okay, and to some extent prescriptive. Fine. So these three we'll try to do. Now, can anyone tell me what is the descriptive data mining? Anyone, please? Descriptive or predictive data mining? Anyone? Can anyone tell me the difference? No? Okay. We'll try to see that. So all of you click on Explorer, please. How do I know that we're all going together? Okay. So, right. So can I assume that we're all ready with WEKA? Otherwise, if you install your WEKA and be ready. Okay. Right. So now All of you go to WEKA Explorer. Can anyone tell me what is the main thing required for your data mining or data science or data analytics? What is the hero of this subject?
Data set
Okay.
itself,
Yes,
data
please.
set, data
Data
set.
sets, right? Yes, data sets. Right. I will be assuming that majority of you are new to WEKA. Okay. So let's create our own data set. All of you can please go to, by the way, WEKA has its own file system called as ARFF. Fine. Attribute relation file format. Okay. So this WEKA already gives you a dump of certain data sets. Fine. So I have installed my WEKA in D drive. Okay, so WEKA has created a folder called WEKA-3-9-5. Similar kind of directory should be there in your computer. Please go to that folder. Okay, if you go there, you will have a data folder. Right? So open your data folder. If you see here, WEKA gives you a number of data sets for you to work on. Fine. Now, as I told you in the beginning, data science is a big umbrella which has so many other areas. Okay, so data science covers data analytics and data mining, etc., etc. All these are covered there. They're all new terms, but the differences are vague. Okay, so all of you open diabetes data set. So you just have to select the data set which you want, click on it,
Yeah, excuse
and
me,
click on open.
sir.
Yeah.
Can you once again show the path of this file, please?
The installation, sir. Okay.
No,
Now,
no, installation is done. Yeah, yeah. This file, how to go to this?
so where did you install the file? Now I have installed in D drive. If you have not given any folder, the default folder, click on C drive. Okay. Go to program files. Click on C. Then go to program files. In that program files, you should have your WEKA directory.
Yeah,
Please,
I have WEKA. Okay.
if you have used default installation, just click on next.
Yes,
Simply
sir.
go to
Got
C
it.
drive, program files, and then your WEKA. Okay, if you double click that folder, you will have a data subfolder.
Okay, sir. I have got it, sir. Thank you.
Right, done. So all of you please open diabetes data set. Okay. Now, since time is less, I will be going a bit fast. Okay. So, and I will be assuming all of you are working on WEKA along with me. Right. I will assume all of you have opened your diabetes data set. You can open any data you want. Okay. But before going further, for those of you who are new, I've told you that the whole of data science revolves around data. Okay. And that your data consists of set of rows and columns. Okay. Columns are called attributes. Rows are called instances. Okay. So columns are attributes. Now, as I told you, there are two very important types of data mining: predictive and descriptive. Okay. In predictive data mining, fine, you are trying to predict the value of some attribute. Okay. Now that attribute, WEKA calls it as a class attribute, right? Now you see, if all of you have opened this, your data set, look at the right side, there is an edit button. Click on edit button, you can see your data set which you have just loaded. Okay. So this is the data set which we have loaded, which you have opened, right? Now WEKA assumes the last column as your class attribute. The last column as your class attribute. Fine. Now, if your last column is not your class attribute, you should open your data in some text editor and manually shift that column to the last. Understood? Otherwise, the default data sets given by WEKA will have the class attribute as your last column. Okay. Now, this data set is about people who are likely to get diabetes based on certain conditions. So the doctor will collect the data about a new patient who comes to him or her. After collecting the required data, fine, the doctor is interested in trying to find out whether this patient is likely to get diabetes or not. Right? So normally humans can predict, but it is not reliable. So we want to rely on machine learning for that. Fine. So in those cases, we will use tools like WEKA. So this diabetes dataset, just understand there are some parameters. Okay. Those parameters will be recorded for patients who visit the doctor or the hospital. And using that collected information, we are trying to predict whether a patient is likely to get diabetes or not. Right? So that will be your, so what is your class attribute? Let's see. Now, WEKA is a tool. Remember, you don't have to do any kind of programming. So non-computer science background people who are interested in doing research, preliminary research, okay, on simple data sets. Okay, I mean not big data like social media data sets or Twitter data sets, right? Or images or videos or text documents. I'm not talking about those. I'm only talking about data sets which are in the rows and columns format. Fine, rows and columns format. For such kind of data sets, and for for those people who are not interested in doing programs or programming, this is the best tool. Okay, so WEKA is a collection of machine learning algorithms. It's a toolkit, right? Now, once I have loaded, right, you see, if you are interested in trying to save your file in a different file format, let us say this ARFF file format is local to WEKA. No other tool can understand it. No other software can understand it. So let us say you are interested in trying to convert it into Excel. Okay. Now, let us say comma separated file format. You see on the right side, there is a save button. So click on save. Okay. Select the place where you want to save your file. Give the name. Right. So just remove this .arff extension. Simply select the type of file you are trying to save. Okay. In this case, I want to save as a comma separated file format. Okay. Which is so that I can easily open in Excel. So you just have to select the file type and simply click on save. If you click on save, what happens? You will get a new file with a .csv file format. You see, this file has changed. So let me double click on it. You see, I'm able to open my file in Microsoft Excel. Okay. So your WEKA is able to open Excel files also, particularly .csv file formats. Fine, your file need not be a ARFF file format. Fine. Any problem until now? So you all know how to load data sets, right? And you all now know for what type of data sets WEKA is more suitable. Okay? It should be rows and columns format only. Right. Now let's move ahead. Now, before doing your analysis, you would like to study more about your data set. Okay? You need to understand your data set before trying to apply your algorithms. Right? So WEKA gives you some basic information. Okay? You see, the total number of rows for my data set happens to be 768. As I told you, in machine learning parlance, a row is called as an instance. Okay, so there are 768 instances. This particular data set has 9 attributes or 9 columns. Okay, and the name of the file is given here. It is pima_diabetes. You see, and all these 9 attributes are shown here. Fine, all these 9 attributes are shown here. Fine. Now, if you click on any attribute name here, to the right, you will get certain statistics, basic statistics, like what is the minimum value, maximum value, what is the mean, and the standard deviation for this particular variable. Okay, PREG. Okay, now what is PREG, PLIS? We are not concerned here. It is assumed that we have already studied the manual for the meaning of these columns. Okay, right. Now, you see the type of data, the type of attribute here is numeric. So you can even know whether your attribute is numeric or nominal. Numeric means values are all numbers, continuous values. Nominal means you have fixed set of values, but they are discrete. Right? So the values are like strings. For example, yes or no. So we have two different values, yes and no. Right? So yes and no are nominal in nature. Like if you are interested, if you have a attribute with names of customers, let us say, that's a nominal attribute. Right? If you have an attribute which has age column, that's a numeric attribute. Fine. So if you click on class, let us say, okay, you see here, this class attribute has two values. What are those two values? You see on the right side here on the top, just above this colored columns, tested negative and tested positive. Okay, tested negative and tested positive. There are only two values. So we have this data set which is historical in nature. It is assumed that data has been collected for all patients in certain for certain variables, and that they have classified that particular patient either having tested negative for diabetes or tested positive for diabetes. Okay, so this is history. This we already know. Okay, so there are 768 people for which we already know whether they have tested positive or negative for diabetes. So in machine learning, fine, there are two types of machine learning, supervised and unsupervised. Okay, so let me go there and show you. Fine, you see, one is supervised machine learning, one is unsupervised. See, machine learning, data mining are synonyms. Okay, they are all synonyms. Learning. Fine, in learning, by the way, if somebody asks you, learning derives from what? Learning derives from artificial intelligence only. So learning is one component of AI, right? So you have supervised and unsupervised learning. Okay, most frequently used learnings. So in supervised learning, we are interested in trying to predict the value of some attribute based on values of some other set of attributes. Fine. So we want to develop a model using our WEKA. Okay, develop a model using WEKA to predict values. Okay. This diabetes dataset is present in WEKA's tool itself. It's in the WEKA tool only. You just have to go, you just have to click on open file. Okay, go to the folder where you have installed your data. For example, I have installed in D drive. So I am going to D drive. You look for this folder called WEKA followed by the version of your WEKA. Double click on it. You look for your data subfolder. Double click on it. You have so many files. Okay. So I just at random selected diabetes file. That's it. Remember, this ARFF is a peculiar file format specific to WEKA only. Right? Right. So we all have opened our data set now. Right? And we are now, I will assume you have your own data set with you. Fine. You can open the data set in WEKA now itself. No problem. Mind you, I have told you the file format, right? The file structure should be rows and columns only. Okay. And right now we are looking at supervised learning, which means you are interested in trying to predict the value of some attribute. The value of some attribute. Okay. The name of that attribute which you are trying to predict is class attribute. In WEKA, you have to make sure your class attribute is to the last. Okay, fine. Now let's see. Let's try to understand briefly the distribution of our attributes. Okay. Now I have clicked on class. Clicked on my class attribute. What do I see? I see that there are only two values for my class attribute. Okay. So correspondingly, you have two different colors shown here. Simply point your mouse on this blue bar. What do you see? You see tested negative. And in brackets, the number of instances which have tested negative as your class value. Okay. Similarly, if I point the mouse pointer over tested positive on red color, this red color indicates tested positive. Fine. And the number of instances which has tested positive is 268. Fine. So it's a binary class problem. This is called as a binary class problem. Right. Now, if you have more than two values for your class attribute, it's called as a multi-class problem. Okay, multi-class data set. And accordingly, you will do your machine learning. Okay. Now, you see, you click on any other attribute to the left here, you see left side, any of these 9 attributes to the left. You click on any of the variable to the right, you will see the distribution. Okay. This is looking almost very near to normal distribution, right? You see PRES. Okay. Just click on your attribute. This is looking like more nearer to a normal distribution, right? Now, can anyone tell me the interpretation of this this color, please? this visualization here. So WEKA automatically is allowing you to analyze your variables, your variable distribution. Okay. So you can write in English in your paper in describing about your data set. Okay. After introduction part of your paper, you can simply write one paragraph explaining all the attributes of your data set simply by using this explorer. Click on any variable, look at this visualization, and then interpret it. Okay. If you want to see all attributes at the same time, the distribution, simply click on visualize all button here. Okay. So if I click on visualize all, you'll get this. Okay. You can directly use this in your paper itself to describe your data set. Right. So you people are, you can interpret them properly. People. Okay. So if I see that PLAS, PRES, and mass, these three variables are following normal distribution. The rest of them are having a skewed distribution, almost skewed distribution, right? Okay. Right. So, so your WEKA has, where is this? Yeah. So you can describe your data set, all your variables by visualizing this and try to interpret them. Right. Now you see, let us say if I put my mouse pointer here, I see a value 137. Right? Can anyone of you please tell me what is the meaning of that 137? You see, if I simply move my pointer over, you see the numbers are changing. Can anyone interpret this, please? Statisticians, we are very poor in statistics. Can anyone please explain this? Sample any very attribute you can take and explain, please. If we are able to do this, we'll go ahead. So, anyone please? Let us say PRES. This one to the right. Anyone, can you explain this visualization?
Those numbers represent the count in that interval.
Count. Okay. Count of what? It is count of the number of instances, please.
Yeah.
Next, what are these blue and red telling us? Anyone, can you see if I take 136, let us say, among these 136 instances, which have, see, I'm interested only in PRES variable. Okay, so in 136 rows, if I look at PRES attribute among those rows, or okay, for 136 rows, PRES value happens to fall between 57.4 to 64.5. Okay, and that the it also shows the class distribution for those rows. So majority of these 136 rows has blue color as the class value. Okay, very few have red color as the class value among these 136 rows. What is the blue color class value, please? If you look here, you put your mouse on that, it is tested negative. So 136 people have tested negative, right? Among these 136, right? So that's how you interpret. And that this attribute is following the normal distribution, very near normal distribution. Okay. You see, okay. Let us go back to Explorer and see what is the range of this PRES attribute. So go back to your Explorer. What is that? PREG, right? So if I click on PREG, what is the variable you are looking at? PRES. Okay. You click on PRS here. What do you see? The minimum is 0 and the maximum is 122. Right? So that's what is given here. You see in the x-axis, 0 to 122 are the values. Okay, among 0 and 122, the majority of the values are falling in this range, approximately. Okay, so lots of interpretation you can do. So how did we get this? We simply clicked on Visualize All tab. Click on Visualize All tab. Okay, so this is a numerical data set. You click on Edit button. You see you are able to open your data set here. You see all the values are numeric. Okay, but the class attribute is nominal. Class attribute is nominal, which means there are fixed values. Okay, there are only fixed number of discrete values. In this case, only 2 values. And I'm trying to learn a model which can predict either of these two, either tested negative or tested positive for any unknown patient. Okay, for any unknown patient. Can anyone kindly tell me how do I represent a patient here? In my data, how do I represent one patient, please?
One row.
One row. Thank you, madam. Thank you so much. I hope all of you are all along with me. So every row pertains to one patient, and values about every patient will be your values of your attributes. Right, fine. So this is your preliminary description of your data. So when we do our small project, I want all of you to write down such kind of information in your notebook. Okay, right. Now, WEKA provides, so before applying, before doing machine learning, before doing data mining, okay, we have to observe, are there any problems with our data set? Are there any problems with my data set? Okay. Now the problems, what kind of problems can we face? Real world data usually can have missing values, fine, or it can have noise or wrong values, or it can have a number of outlier data, okay, values which are not pertaining to the commonly accepted range, right? So very high values or very low values, they are called outliers, right? So, and your file may be too big to operate upon. Okay. By the way, there is one restriction in WEKA. Your entire file should fit into main memory of your computer. If your data cannot fit into main memory, you cannot work on WEKA. Okay. That's the drawback of WEKA. Fine. Now, so let's try to, so if we have problems on my data, I need to pre-process my data. Okay, I need to pre-process my data, right? So all pre-processing algorithms in WEKA, they are called filters. You see in the pre-process tab, there is a filter, a part here, you see this text box, right? So simply click on choose under filter. Okay, so WEKA divides all your filters into 2 types, supervised and unsupervised. Not much of a difference is there between these two. Okay, it's a bit confusing. So unless otherwise mentioned, you work with only unsupervised filters. What is a filter, by the way? A filter is a pre-processing algorithm which is used in WEKA to pre-process our data. What do we mean by pre-process the data? Either removing missing values or filling missing values with some particular value, removing rows or removing columns, data reduction, trying to reduce the size of the data. Okay, remove noise or add noise in your data set. Introduce new columns or introduce new rows in your data set. There are so many things you can do. Okay. So all these things are called filters in WEKA. Okay. So the first thing is you have to observe whether your data has any missing values or not. Okay. So you simply click on all these attributes and see whether you have any missing values. Look at this right side here. In this case, PREG attribute has no missing value. Similarly, I click on PLAS, no missing value. PRAS, no missing value. So it so happens this is a very, very idealistic data set in that no attribute has any missing values. Fine. But in real world, you might be having so many missing values. Okay, what is this? Okay. Yeah, it means among 136 rows, okay, for this column, particular column PRES, the range of values for that attribute is between 57 to 64. Okay. And among these 136 rows for this attribute, okay, you will see based on the color, let me click here now. Based on the color, what is the value of the class? So your class, you see, majority of these 136 you have in this point, in this bar, majority of the class value is only blue. So what is my interpretation for this PRES? With values between, let us say this is 60, between 60 to approximately, let us say around 60, 70, 80, 90, 100, 110, okay, 60 to 70. Okay, for all those rows with PRES attribute, okay, with PRES attribute between 57 and 64, okay, this is the class distribution. Okay, the class distribution is majority of them have blue. What is blue? Tested negative value as class value rather than tested positive. Okay, for that particular row, by the way, for that particular row. By the way, okay. Right. So, see, this may not be of use for everybody, but people who are writing a research paper and who are trying to introduce their data set for the first time, okay, these statistics are of great use for us. And I am talking about those people who are not interested in programming. They just want to use a tool. Okay, they just want to do work fast. So this WEKA allows you to do work fast. So you are able to find out the mean, standard deviation, minimum and maximum for all the numeric attributes. Okay. Right. You're also able to get the count of a nominal attribute. Right. So among, if you take your class attribute, tested negative, 500 rows has tested negative. 268 rows have tested positive as the class value. Fine. Now, since this data set is very, very idealistic, let us try to generate our own data set. Okay. Before going into that, let me, so just click on this choose button. Go to, just click on this arrow, small arrow you're seeing, right? Click on unsupervised. See, there are two types of filters, attribute filters and instance filters. Attribute filters can be used to apply on attributes or on columns. Instance filters can be used to apply on instances or rows. Okay. So majority of, so let us say I want to take up, I want to sample my data. Okay. I want to divide my data into two parts. So I will click on this resample. Okay. If you just hover your mouse pointer over that filter, you see you have a lot of explanation given about that filter. What is the resample filter saying here? Right? So it produces a random subsample of a data set, either using sampling with replacement or without replacement. Okay. So I have selected my resample. For every algorithm in WEKA, you may have to change the parameters. If you want to change the parameters for resample, let us say, simply click on this, right click on this white text box or on resample. So if I click, you are getting a dialog box. Fine. You are getting a dialog box. So in this dialog box, right, you have to give how much percentage of data you are interested in removing or trying to break. Let us say my sample size, I keep it as 60. Okay. I click on OK. Then you see on the top, you have your apply button. Click on apply button. What has happened? You see, out of 768, 460 have been retained. The rest have been removed. Right? So now, and you see, what did we do? We have used with replacement, by the way. Okay, because no replacement is false. So the sampling is with replacement. So you got 460 rows out of 768. You can save these 460 rows. So you simply click on save button on the right. Click on save button and select the directory where you want to save. Decide the file format you want to save and simply give the name of the file. Click on save. Right? You will have a separate file with 460 values. Okay. Now again, click on this this resample. You'll get the dialog box. Okay. Now you see, if you want to undo any changes on your data, what changes we have done? We have applied resampling, right? If you want to undo, simply click on undo button on the top. If I click on undo, you see, you will get back your 768, your original data set again. Fine. So I hope all of you understood how to apply filtering. You just have to click on choose, right? Select the category, select the filter you are interested in, click on that and change the parameters, click on OK and click on apply. Whatever changes you have got, okay, after applying the filter, you can save that. You just have to click on save button, save wherever you want. Okay, so we now know how to divide our data into two parts. Fine. This is one. You see, there is one more called remove percentage. Okay, so you click on remove percent. What does it do? It simply removes a given percentage of data. Fine. So let us say my percentage is 50%. I click on OK and I click on apply. What has happened? You see here left side, you see there are 384 now which have been retained. It is the half of your 768. So if you want to do, you want to remove certain, simply shave off, cut off the number of rows. You can use remove percentage also. Fine. Are we all on the same page? We should be on the same page. Okay. Right. So if you have your own data set, beautiful. Thank you. If you have your own data set, you can open now itself in WEKA and you can write a small report about your data set description. Then you can identify the problems or issues with your data set. Okay, so let us try to create our own data set. Simply one very small data set and try to look at some filters, one or two filters before we move ahead. Okay, I have already created one simple. You can open your Microsoft Excel. Okay, open your Microsoft Excel. Now I have already created this. Okay, so let me open this. See, this is one very small data set I have created. Can you all create this data set for me on your system, please? All of you kindly create this data set and simply save it as, okay, comma separated file format. Go to Microsoft Excel and create this data set on the same lines. Will you do that? It's a simple random set of values. It has no meaning. See, one requirement of WEKA is that the first row of your data should have column names without space. Column names without space. Okay. So in this case, I have created 4 columns. I've simply called them as A, B, C, D. Have all of you created this data set for me? Anybody who has created? Okay.
Yes, sir.
So assuming this is given, kindly observe the values. Okay. I assume that you have created and saved it as a CSV file format, comma separated file format. Okay. Comma. Right. Go to WEKA Explorer. Go to preprocess tab. Open your file. Okay. Go and open your file wherever you have saved it. So let me open. It's a CSV file format, right? So this is my file. Okay. If I click on my edit, this is what I get. Now, for some algorithms, like regression algorithms or neural network based algorithms, your data should be in normalized form. Fine. There can be a requirement from the algorithm itself that your data is in normalized form. What is normalized form? All column values will be scaled to either 0 to 1 or -1 to +1. Okay, they all fall between 0 and 1. So regardless of the range of values for columns, all values, all attribute values will fall between 0 and 1. You see, this is a numeric data set for me with lot of values. Scales is different, right? You see the last column has 1000, I think. Right? The last column has 1000. So 1000 dominates all other values. 6000 dominates all other values. So machine learning algorithms tend to get biased using these large values. So if you want to reduce the ill effects of large values, so you would like to normalize them. Okay. So it's a pre-processing algorithm. So just go to WEKA filters and look for normalize. Okay. Now we are interested in attribute filter. So go to attribute filter, click on normalize, right? Then you click on this text box, you will get a dialog box. You can change your parameters. They are called hyperparameters. Now you see there is something called ignore class. Make it true. If you make it false, the last column will not be applied. The filter will not be applied on the last column. Okay. So I've just made it true. Okay. Click on OK. Then click on apply. Right. So filter has been applied. So click on edit. You see what happened? All the values have been normalized from 0 to 1. Okay. So there is no chance of any kind of a bias or a value or attribute dominating over other attributes. So this kind of analysis you might do on your data set, right? Now you would like to save this file. Simply click on save and you save wherever you want. So that file will be your normalized version of your data. Next time you can always open your normal file, your file with normalized data. Okay, it's up to you. Similarly, see, I'm clicking on undo. I'm undoing things. Similarly, you have a standardized filter. Okay, standardized filter will standardize your data set with zero mean and unit standard deviation. Okay, if you want to do that, you want to create a standard normal distribution for your variables, you can apply this standardized filter. You can apply this standardized filter. Okay, you see, let me apply this. I've applied. Click on edit. Okay, you see your values have changed here. Your values have changed. Similarly, you see, you click on A, you see the mean and standard deviation have changed to 0 and 1. Okay, whereas D has not changed. Why D has not changed? Because in standardized, you see, if you open the dialog box, your ignore class is false. If you make it to true, click on OK and apply, then only the class attribute. Remember, in WEKA, the class attribute is the last column. Fine? Last column. So that will also be selected. So if I click on apply and click on edit, you see the last column also, the filter has been applied. Fine? So there are so many filters here. So many filters here. You can convert nominal to binary also. You can convert nominal to binary. Let me open a file which has only nominal values. You see, we have 3 columns in this sample data set with only nominal values. Okay, I told you nominal means fixed finite set of values, but they are discrete. So the first column you have hello, fine, good, area. So they're all nominal values. Third column, second column Ram, Sham, third column Hyderabad, Secunderabad, etc. Right? So this is a nominal data set. You click on any attribute, you see, you will find here the type of the attribute nominal, the number of unique values, distinct values, missing values, etc. The count of those values also. Fine? Okay. So now for this, let us say, if I select nominal to binary, look for nominal to binary filter. I'll click on nominal to binary. Okay. You click on this white text box. You will get a dialog box with lots of parameters. Fine. You just have to change these values wherever required. Click on OK and then click on apply. Okay. If you click on apply, you simply open in your click on edit. What do you see? You see what do you see? Your A, okay, your A column has 1, 2, 3, 4, 4 unique values, right? So accordingly, WEKA has created 4 columns for 4 unique values. For 4 unique values. And wherever, whichever row has a value, let us say hello, right? In this first column, you will have a 1 here. If you have a 0 here, it means, okay, for this particular row, third row, A doesn't have hello value. Rather, it has fine value. Okay? And the fourth row has a good value. Anybody who has not understood this, please? This nominal to binary. Or are we all on the same page? Yes, please. Are you all able to understand? Okay. Let me go back. So we are looking at filters, by the way, right? Now, so there are so many such filters available. So you know now how to do pre-processing for your data set. Now let us say you would like to do classification. Fine, you would like to do classification. What is classification? Trying to predict a value. Trying to predict a value of some attribute. Okay, that's called as supervised machine learning. Fine. So as shown here, in your supervised machine learning, you see this box. You have various columns. Fine. And then the last attribute is called as your class attribute. You are interested in trying to predict this class attribute. Fine. So this is called supervised learning. There are 2 types of supervised learning. Okay. One is called regression and one is called classification. If the class attribute values are numeric and you are trying to predict a number, it's called regression. If the class attribute value is nominal and you are trying to predict the nominal value, it's called classification. So in this case, this particular table shows it is a regression problem, right? And so we are trying to do supervised learning. We are trying to develop a model. This model, we want to use it in future to predict new values. So what is the process for building a new model? Why do we need a model? We need a model to predict class attributes. Okay, to guess class attributes. In order to predict or guess class attributes, we need to build a model. In particular, a classification model or a regression model. Anybody who has a doubt here? No doubts? Okay, so we are trying to do supervised learning in WEKA now. Okay, so let us see how to build a model. So go back to Explorer, go to Pre-Process tab, right? Open your diabetes data set again, once again. So let's go back to our installation folder. Go to WEKA, go to data, click on ERFF, click on diabetes, click open. So I opened my diabetes set. Okay. Then you go to the classified tab. You see on the top, there are various tabs. So the first tab was pre-processing. Let's go to the second tab to do classification or regression. Okay. Now, if you click on classify tab, you see this classify area. Click on choose. These are all the classification algorithms available in WEKA. Okay, there are so many algorithms available for you to choose for your data set and apply. Okay, let us say I select, there is one algorithm called decision tree algorithm. Okay, this decision tree algorithm builds a tree. This tree, an inverted tree. This tree is called as the model. We will use this tree to predict values. Okay, so in order to predict values, first we have to build the tree. That means we have to build the model. So what is the procedure for building a model? First of all, select your algorithm. So my decision tree is a type of, it comes under this tree section. So click here, the small arrow, you get an expansion and select J48. Okay, it's a decision tree algorithm. So click on J48. You have selected here J48 algorithm. Any doubt here, please? See, there are two types of data mining: predictive, descriptive. Predictive data mining means trying to predict the value of some attribute. Okay. Now, this value, if it's a number, we call it as regression algorithms. Simple. If we are trying to predict a number, or if we are trying to predict the value of an attribute which is numeric, we call this learning as regression algorithms. Right? On the other hand, you will have attributes which have discrete values, like yes or no. If we are trying to build a model to predict such kind of discrete values, it's called classification. Understood, please? So regression is used for predicting numbers. Okay, that's what we will do first. Okay, so please click on classify. Please select whatever values you want. Now for regression, algorithms will be under functions. Okay, so click on this arrow. Algorithms will be under functions, right? So you have your logistic regression, you have your linear regression, etc. So many are there. Simple logistic regression, support vector machine for regression, etc. Okay. Now, if some algorithms are disabled, it means this algorithm cannot be used for this particular data set. So WEKA automatically disables for you. Okay. So what is the data here we are using? Diabetes, right? So for diabetes, I am allowed to use a logistic regression algorithm. So I have selected simple logistic. Okay. Simply click on this table again. You will get a dialog box where you can set the parameters for this logistic regression. Okay. You can click on more button here to get more information about this particular algorithm. So what is it saying? It's saying it's a classifier for building linear regression models. Logic Boost, the other name for this. Okay. So you have to give the various parameters for this. Click on OK. Right? Click on Start. Fine. Now you got some results and in this classifier output window. This is called as a classifier output window. Okay. So what is regression? Regression builds a formula, right? An equation. Right? Dependent variable, independent variable. Y equal to mx plus c form. So this is your equations given here. This is your model. This is your model, okay? And you see, the accuracy of this model is 77%. Okay, so 77% of the rows, this particular regression model has correctly learned. Okay, and it also shows you the time taken to build this model. Now, when you're writing your paper, you can write down these statistics. Okay, many of you know this kappa statistic value, so you can interpret this kappa statistics value. The more, the better, right? And you all agree with me, the error value should be least. So in regression algorithms, you will be using root mean square error, RMS. Okay, root mean square error. You can also, it also shows you relative absolute error, root relative square error. So many error measures are being given. It's your choice. So we have built our model. Okay, now this, you see, there are 4 ways of building your model. Okay, you are just interested in just finding out, understanding your model, just want to train and see, use the first option, use training set. If you are trying to predict unknown class values, okay, use the second one if you want to do prediction. Now for this, the requirement is that you need to have a model. I'll show you how to do this. But if your data set is less, let us say 500 rows or 1000 rows, less number of rows you have, it is suggested that you use cross-validation method to build your model. Okay, so majority of you people might be knowing what is cross-validation, right? Yes, space. So have all of you understood how to apply classification now, how to build a model? It's easy. Go to classify tab, simply choose your classifier, click on this to change the parameters for your classifier, right? You select this 4 ways, one of these 4 ways to build your model. Majority of the cases, if your data set is less than 500 rows or sometimes 1000 rows, you will go for cross validation. And in literature, people have suggested 10-fold cross validation. So the default value for the number of folds will be 10. 10-fold cross validation you will use. Okay, you just have to make sure your class attribute is chosen here. Your class attribute is chosen here. Okay, so if it is not chosen, by default the last attribute will be chosen. Otherwise you have to change whatever other attribute you want to make it as your class attribute. Okay, so I have selected class. Simply click on start. The training would have happened and the model would have been built. Okay, any doubts here, please? See, many of you would be wondering why I am going so fast. Okay, the reason is that we have very short time and I need to complete a lot of components of WEKA. So without worrying about whether you are understanding or not, I am forced to go fast. Right? We have so many other things to see in WEKA. Right? So I'm going a bit fast. If you have any doubt, kindly please stop me. Those who are new to WEKA, have you understood how to build a classifier, please? How to do classification or regression? And did you understand the difference between regression and classification?
Sorry.
How to know? Yeah, yes, please.
Sir, excuse me, could you please tell me how I know that my model is correctly built or not?
There are two answers, sir. One is we will use domain knowledge. Okay. The second answer is simply go to the classifier tab, look at the classifier output, look at the accuracy. Okay. If it is highly accurate, if it is nearing to 100%, you are sure that your model is okay. Okay. You will look at your error statistics. If your model is having less error, you can say your model is okay. Now, mind you, remember we have done only one iteration. That means we have built only one model. You can tweak the parameters of this algorithm. You can change them and simply build a new model with the same algorithm. Okay. So you see to the left side here, so many models will be shown. For if you build 5 models, let us say, by changing different parameters. Among these 5, you look for that model with the least accuracy, with the highest accuracy, by the way. Okay, with the highest accuracy. That you will choose as your model, among others, for that particular algorithm. Or you can look at precision, you can look at recall, you can look at F measure. These are all different evaluation measures given to you, based on which you can evaluate and say whether your model is right or wrong. Okay. The other way is you look at this confusion matrix. Right? Ideally, if your confusion matrix diagonal only is non-zero, then yours is the best model. Or your diagonal should be ideally very nearer to diagonal should be only be non-zero, the others should be zeros. Right? If you see here, out of 445 rows have been classified as A by our model. Okay? Predicted as A. Now, what is A? Tested negative. Okay? And this tested negative is the actual value, the correct value, which your original data set has. And this 445 is the number of rows for which your model has correctly predicted as tested negative. Okay? Similarly, 150 correctly predicted as tested positive. On the other hand, this 55 means 55 number of times the model has wrongly predicted as tested negative. It should have been tested positive, but it has predicted as tested negative. Okay. So you can look at this confusion matrix and also try to see whether your model is okay or not. Got my point?
Yes, sir. Okay, sir. Thank you, sir.
Number 2, sir, number 2, we have experimenter. I will show you. You can compare your model, your algorithm with other algorithms on the same data set and try to see whether your algorithm is performing better or not. So based on that also you can choose your algorithm. I'll show you in just 5 minutes. Okay. Right. So these are the steps to build your model. You see, for all non-computer science people or all people who just want to use it in their particular domains, who just want to apply machine learning, WEKA is very easy. Okay. And learning curve also is very easy. Within 1 day, you can start applying your WEKA tool and you can start analyzing your data set. Right. So this is the steps. Okay. Now you see, before going further, I want to show you one more model. Okay. Let me show you a tree algorithm, decision tree algorithm. I went to trees. I selected J48. Okay. And then if you want to tweak the parameters, you can tweak here. Otherwise, simply click on OK. Make sure your last column is your class and it is selected. Simply click on start. What has happened? You see, this is your tree. This is the tree built and this is the model. Okay. So this model you see for the same data set, the accuracy is 73.8%. Whereas your logistic regression is 77. Okay. So in this case, your simple logistic algorithm is better than trees when you look at the correctly classified instances. Right? You can even look at your kappa statistic also. Right. Now, so you see, for decision tree, you see to the left side, these three, they are called models built. Okay. Now, for trees, right click on trees. Okay. Click on visualize tree. You will get a tree. This is the model built using decision tree algorithm. So for this decision tree, you can visualize your tree. Okay, right click, click on fit to screen. This is your tree built. Right? This is your model. So this tree can be used to predict your unknown instances in future. You can save this tree and reuse this tree for future. Okay, so WEKA allows you to save your model. After you are sure your model is correct and you are pretty happy with your model, you can save your model. Okay, let us say I will show you how to save. Let us say I want to save my tree. Right click on this trees in the result list. Okay, right click and click on save model. Click on save model. Select wherever you want and type the name of your model. Okay. So I have called it as tree underscore model. Click on save. Your model gets saved. All of you have understood this? How to save models? I hope you have understood. For any algorithm you select, you can save your model. Simply right click in the result plane and select save model. Okay. Now, why do we want to save our model? Because in future, when an unknown instance comes and you want to predict the class value for that unknown instance, how do you do that? Or you are asked to build a model for, let us say, ICICI Bank. You are trying to build a model which predicts, which has to predict whether a bank loan has to be approved for that customer or not. So you would have built your model. After you are sure your model is accurate, you will give this model to your customer, to this bank. So the bank people will use your model to predict unknown instances. So when a customer comes, the bank will collect all the data of that customer, right? And supply this data to your model. Your model will predict. Your model will predict, right? So that's the use of saving models. Fine. So you see, for regression, you go to functions. Okay. For classification, you can use any of these. There are so many algorithms available, right? So you just have to read the literature, find out what algorithms are there, see whether those algorithms are there in WEKA or not, select the algorithm in WEKA, okay, apply them, change the parameters, keep applying, keep building new models based on the changed parameters. Select that model with the best accuracy. Okay, that's what you can do. So have all of you understood how to build models, please? Right. So let me go ahead. We will try to do a small project. Okay. Are all of you having your systems ready and your WEKA is open, right? Shall we do a small project? All of us? Okay, because if you want to apply more than one function, I understand that function means an algorithm. Okay, you cannot do that in Explorer. You cannot apply more than one algorithm on one data set at a time. If you want to do that, we'll have to go to experimenter. Okay, we have to go to experimenter. Now, let us do the small project. Okay, all of you simply open your diabetes data set once again. If you have not yet opened it, okay. Let's not do with the diabetes. Let's go to iris. All of you open iris dataset, please. See, the aim is to do a small classification project. Okay, this classification project, if you understand, you can follow the same thing on your own datasets, right? So to remove the boredom, to make ourselves more exciting, I want every one of you to do on your own. Okay, I'll keep telling all of you do it. Are you all okay for that? I hope all of you are okay. Done. Please open iris.arff in Explorer. Please open iris.arff. I have typed it in the chat window. How do you open? Somebody can anybody help me? You have to go to WEKA Explorer, right?
Yes, sir.
Next, go to open file. Go to your installation directory. Go to data subfolder and select iris.arff. All of us, let us open parallelly. Let us do this parallelly. Okay. So select iris.arff, click on open. Have all of you opened iris? I'll wait for 1 more minute. See, I see approximately 144 participants. So I want all 144, including me, to follow the steps. Let us all open iris. Done? Very good. All of you, one of you tell me the preliminary description of iris dataset. One of you, you can unmute yourself and explain the basic information about iris dataset. Any one of you, you can unmute yourself. Please take initiative. See, I am assuming all of you are writing a research paper. All of you have some data set, be it in the area of chemistry or statistics or physics or maths, some data set you have for some problem. You want to put machine learning into your research. That is our aim. For that, you want to use WEKA tool. Okay, nowadays, machine learning, if you put into your project has a very high probability of getting accepted. You all will agree, right? One of you, can you explain this data set, please, for me? How many instances are there for this data set? Anyone? See, all of you, please do parallelly. Yeah.
150.
150 instances. Beautiful. How many attributes are there?
5.
Beautiful. Thank you, sir. Then kindly tell me how many class values are there?
3.
3. Can
3.
anyone name those class values?
Setosa, verrucular, versicular.
Iris setosa, iris versicolor, iris virginal. By the way, this data set is about a flower called iris. Some researcher has collected 150 samples of this iris flower, and he found out that there are 3 different iris flower species. So this researcher has named them as iris setosa, versicolor, and virginica. It so happened that all these 3 species are total are 50, 50, 50. Right? How many attributes are there for every flower? Anyone? How much data is being used to describe one flower? 4. 4, right?
4.
4 different
4
parameters have been chosen. Sepal length, sepal width, petal length, petal width. They are used to describe one flower. So we have 150 flowers. Beautiful. Are there any missing values for any attribute? Kindly check. How do you check?
No.
Simply select each attribute and see on the right
No.
side. We see that there are no missing values. Beautiful. Okay. If I take sepal length, one of you tell me in English in one paragraph about sepal length, about its range, etc.
Its minimum length is 4.8, maximum is 7.4, mean is 5.8.
Standard deviation. Beautiful, sir.
0.84.
So, and we are not worrying about how to interpret standard deviation 0.8. Okay, mean 5.8. That is not our worry. Okay, that all of you can write down. So you by now you would have written 1 page of description for your data set. Okay, now all of you click on visualize all. Is there any attribute which is very nearer to normal distribution?
Width, sir.
Super, sir. Thank you. All of you understood? There is one particular attribute which is following approximately 1 or 2 attributes are following normal distribution, right? Sepal width is very nearer sepal length to some extent, right? Okay. Is there one attribute I can use to distinguish between 3 types of flowers? Can I take the help of any attribute using which I can distinguish these 3 types?
Sepal length.
Sepal length, sir? No. Why? Because you see there is a overlap. Blue, red, and that sky blue, there is an overlap of colors, right? So if there is an overlap, what does it mean? You can't use sepal length to distinguish between rows with unique class values. You look at petal length.
But that
also we have, yeah. That also we have. Very nice. But if somebody asks you nearest attribute, what shall we take?
So in that case, petal length can be taken.
Petal length. But that is not the correct answer. We will not say petal length is used to distinguish. So let us conclude in our project that we begin distinguishing between our class, right? Right. How many rows are there for each class level? 50, right? Okay. Are there any non-numeric attributes? There are no non-numeric attributes for the class. Okay. Is the class attribute balanced or unbalanced? It is balanced, right? Why class is balanced? Because there are equal number of instances. Okay. So you should have got around 6 to 7 points to describe your iris data set. Okay. Right. And if your data set has any problem, let us say missing values, what do we do? What shall we do? Anyone, can you suggest? See, if there are many, if lot of values are missing, you can consider removing the attribute. If for a particular attribute there are many number of missing values, you can consider removing the attribute itself. It is of no use for our further analysis. Otherwise, you can fill your data set, your missing values with certain values. Okay. So you can go to filters. You see, there is something called replace missing values. Use this to fill your data set with some value. Okay. In this case, the filter will replace the missing value with the mean for a numeric attribute, the mode for a nominal attribute. Anyone who has not understood? Yes, sir. For your particular data set, let us say you have got many missing fields. What will you do? You will use this particular filter, replace missing values, and you try to fill up. Okay, or you try to remove. Any guesses? How can we remove attributes? Any guess? Easy. Here itself. Okay, you see, you can select any attribute you want and simply click on this remove. Here itself, you can remove your column for further analysis. Okay. Let us say I click on these two and I click on remove. What happened? It has removed 2 columns. Happy. I can simply save this new data set. No. You want to undo. Simply click on undo. Done? Right. So, looking at the visualize all, what is the conclusion we have done? We can see an overlap of class values and there are different distributions for different attributes. Okay. And the sepal width to some extent is following Gaussian distribution, right? Normal distribution. Okay. Right. Now, all of you go to visualize tab. See, someone asks you to find out the correlation between 2 attributes. Can any one of you tell me what is correlation, sir? See, it is very important before applying your machine learning to find out whether there is any correlation between attributes. Okay, there are various ways of finding out the correlation in WEKA. I'll show you the easiest way. Simply click on visualize tab. Okay, this is called as a scatter matrix. See, there is something called as a scatter plot. Scatter plot is used to graphically see. See, this is a scatter plot. To graphically see the relationship between 2 attributes, one on x-axis, one on y-axis. Okay, and you can find out here whether there is any correlation or not. Okay, if all values are going up or all values are coming down, we say there is a correlation. Right? Okay. Now, See, all of you look at this point size. Default is 1, right? Change it to 3 or 4. It's up to you. Okay. Point size I have increased to 4. Increase the jitter also to some extent. And click on update. All of you have done that? Yes, please. Are all of you on? Or we see we are doing a small research problem. Okay. So assume you are using your own data set. Nobody has done any work. Nobody has applied any machine learning on that data set until now. So you have loaded your data set in WEKA. You did some preliminary study of your data set and you made a small report. You would have identified some problems. Let us say you identified missing values. See, I can show you, but there's no time. Okay. So you can remove missing values, you can remove noise, you can remove attributes, columns, etc. Okay. Then you are trying to find out whether there are any two attributes with correlation. Correlation means if one attribute value increases, let us say the other attribute value either increases or decreases. So there is a relationship. So you can have either a positive correlation or negative correlation. Right? So for that, what did we do? We are trying to use a scatter matrix for that. So we have increased the jitter and the point size and we have clicked on update. This is your scatter matrix. Okay. Now, can anyone identify any correlation in any of the attributes? Look at pattern width and staple length. This one. Anybody, can you explain whether there is any correlation? Any other observation anybody can do? One very important observation you can write in your paper. See, there is very clear separation of, right? Very clear separation of rows. You agree? Very clear separation of classes among the rows. Right? So this similarly sepal length and petal width. Right? This one. This one. So there are some scatter plots you can see and simply say that we see some separation of class values between these two attributes. Okay. So without wasting time, we can say that we can use linear algorithms for this data set. We don't see any significant correlation. We see clear separation of class values among different rows. So this is a very simple, straightforward data set, right? We can use linear algorithms happily. Remember the Occam's razor principle? We will use linear algorithms. Okay. Right. Now I want you to analyze, right, 4 machine learning algorithms on this data set and give me a conclusion which algorithm is better performing on this data set. Right? That is the question asked to you. Okay, can we do this in Explorer? Can we do this in Explorer, please? Anybody? No. You cannot compare, you cannot compare multiple algorithms on the same data set using Explorer. Okay? See, before applying machine learning, you have to analyze which algorithms are suitable for your data set. Okay? Which algorithms are suitable? To do that, you would like to apply various algorithms on your data set, do an analysis, do evaluation, take a conclusion saying that so and so algorithm is performing better. Then all of you are understanding what I am saying. Okay, let's do that. We can't do that in Explorer. Okay, so let's close all these windows. Oh, okay, not this one. Let's go back here. All of you click on experimenter. I have opened experimenter window. All of you open experimenter, please. Please click on experimenter. All of you opened the experimenter. I know many of you are sleeping. No choice for me. And we have very less time to do a lot of things. Already we have spent almost 2 hours. Okay. So I assume all of you opened your experimenter. Done. One of you tell me what is our aim? One of you tell me what is our aim? Our aim is to evaluate multiple algorithms on our data set and identify the best performing algorithm for our data set. Okay. So this is our experiment. You see, there is a new button on the right side. New button. Okay. By the way, left side on the window you see experiment configuration mode. There are 2 modes. There are 2 modes, simple and advanced. Majority of cases simple is enough. Okay. Default is simple. All of you click on this new button. Okay. All of you have clicked on new button. Done. Now, what kind of experiment type? Left side, all of you select as cross validation. It is default. Then what do we want to do? Classification or regression? Let us do classification. Okay. We are trying to analyze classification algorithms on our data set. Okay. Come down. You see data sets. Left side down. Right. We have to select our data set. So click on add new. All of you select your data set. Let us select iris. I have clicked on add new. Go to your installation folder. Select your iris data set. Click on open. You see your data set is open here. Are all of you on the same page? Yes, please. Done. Now, see, if you want to do, let us say you have multiple data sets. You want to do performance analysis on multiple data sets using multiple algorithms, you can do that. In that case, you have to add multiple data sets here. So you have to click on again add new, select your second data set. Let us say vote. Okay. Click on open. So you have 2 data sets here. Now I don't want to do that now. So if you want to remove your data, click on that. You click on delete selected button. Okay, on the top, you see here. So click on delete selected. selected, the data set is done. Now we have to select our algorithms, right? Right side you see algorithms. Click on add new. Okay, I'll tell you the names of the algorithms. All of you select. We will select only 3 algorithms, right? Okay, before going to that, there is something called baseline performance. Baseline performance. Okay, there are 2 baseline algorithms in WEKA. The basis, the line, the least. With respect to this baseline, you are going to compare your algorithms. Okay, so if one algorithm performance is less than this baseline, it is a waste. You simply remove that algorithm. Anyone who has a doubt? So this baseline, there are 2 algorithms in WEKA. All of you remember. One is 0R algorithm. One is 1R algorithm. Okay. So for our experimenter, see, let us select 0R. It is by default selected as 0R. So click on OK. You see 0R is selected here. Right? All of you select iris. All of you select J48 from decision tree. All of you select IBK from lazy. J48 and IBK. Select them here. You simply have to click on add new. Okay, and add. So click on add new. Click on choose here in this dialog box. Okay, go to trees. Click on J48. Click on OK. Right? Add new. J48. Okay. Then similarly add new. Go to choose. Go to lazy. Click on IBK. In IBK, you put the value as 3 for this KNN. K nearest neighbor algorithm. Okay, the number of neighbors we want is 3, not 1. So select this, change this as 3, click on OK. So we have 3 algorithms selected. All of you have done this? It's a big theory, sir, 0R and 1R. By the way, there is a textbook written by the people who have written WEKA. There is a textbook, sir. The authors are Ian Witten and Abe Frank. These two people have written a book on data mining. Okay, they have explained the 0R, 1R and everything about WEKA in this book. So search for this book. You can buy this in Amazon also. Okay. The 3 algorithms are J48. I'm typing here. J48, IBK, 0R. Okay, 0R anyway is the baseline. So we are simply comparing 2 algorithms with 0R. Okay, I'm trying to save time. Right. So your experimenter should look like this. Your experimenter should look like this. Done? Okay. Now go to the top. There are 3 tabs on the topmost window, left side. Set up, run and analyze. So we have set up our experiment. Okay. Now click on run tab. You should see this window. Click on run tab. You should see this window. Okay. Now click on start. You will get the result like this. There were 0 errors. All of you should get this message. All of you do that. All of you do that. So all of you have got 0 errors. We have run the experiment. We have set up the experiment. We have run the experiment. Any problem anybody is facing? So we have used 2 algorithms and 1 baseline algorithm 0R. By the way, most important point in experimenter, see, make sure the baseline algorithm is always the first here, right side. Baseline should always be the first. 0R should be the first, then followed by your algorithms. Okay. Done, sir? Anybody, any problem? Right. Okay, now go to analyze. Go to analyze tab. Right. Now our experiment setup is there in the main memory. Right? It is there in main memory. So simply click on this experiment button to the right on the top. Click on experiment button. Your experiment will be loaded from memory. Understood? All of you have got this? Just like me? Okay, so I've clicked on this experiment button. Okay. Now you see, I have to, my experiment is set up. Okay. I have run my algorithms on my data set. Now I want to see the results. Okay. So you see, go to the left side top. There is a button called perform test. There is a button called perform test. Click on perform test. Click on perform test. You will get results of your experiment here. Your analysis results are in the test output. All of you do that. All of you have clicked on perform experiment. Perform test button. Yes. Perform test. Now carefully understand the results. Okay. Carefully understand. How many algorithms we have? 3. So you have 3 columns. Okay. How many data sets I have? Only 1 data iris. So you have 1 row. Okay. Any problem here? I'm looking at the chart window so that anybody will put a message. No messages, so no problem. Right. So you see 3 columns. Now carefully see the baseline algorithm performance on iris data set is 33.3. So the accuracy is 33.3. So the worst thing to happen, the worst accuracy is 33%. Okay, that is my baseline. So if any algorithm's accuracy is less than 33, junk it out, remove it off. One of you tell me, what is the accuracy of J48? Any one of you, please? What is the accuracy of J48 and IBK?
It's 94 and 95, sir.
Thank you, sir. Now you see, sir, there is a V symbol after those values. We have 2 V's there, no? A V means this 94.73 performance is significantly better than the baseline. V means better. Okay. On the other hand, if you see a star, star means that algorithm is not performing properly. Okay. You see here this. If you see here, there are 3 fields. Okay. One field is, the first one is V. V means better. So you see under 94, there is a 1 here, right? It means decision tree is better than 0R. Okay. Similarly, for lazy IBK, there is a 1 here in the first field. That means V. That means its performance also is better than 0R. Done? So you may get a case where sometimes there will be a 1 in the last field like this here. If there is a 1 here, it means you will see a star here instead of V. Okay? It means it has performed badly. It has performed badly over the baseline. Okay? And my observation is that IBK, the K nearest neighbor algorithm IBK, is performing better when compared to the other two. When compared to the other two. Right? So what will I do for my further analysis on my data set? I will select what algorithm? The lazy algorithm, the nearest neighbor algorithm. K nearest neighbor algorithm. By the way, what is the K value we have selected? Anyone? Do you remember? Did we do that? Go back to setup.
3.
3, right? Oh, you see here 3. You have changed it. Okay. You have 3. So the K nearest neighbor algorithm with K equal to 3 is performing better than decision tree for my iris data set, and that both these algorithms are significantly better than the baseline 0R algorithm. So what do? You simply have to select your K nearest neighbor with K equal to 3. So you go back to your Explorer, go back to classify, select your IBK, okay, from what? From lazy, right? Go to this parameter, change K to 3, click on OK. Okay, make sure your class attribute is selected. Fine. And make sure use training set is selected. Don't forget that. Use training set is selected. Click on start. Okay. Now you got your model. This is the model I want to use for my further analysis. Okay. All of you understood this, sir? Any problem here? So for our data set, for our research, after doing analysis on 2 different algorithms on my data set, using the baseline algorithm as 0R, I found out that the K nearest neighbor algorithm with K equal to 3 is better. So for my further analysis, I will use this algorithm. Okay. For that, I will have to save my model. Okay. I will take 5 more minutes. Madam, organizers, can I just take 5 or 10 minutes more, please?
Yes, sir. Yes.
Sir, excuse me.
Yes, sir.
Sir, for K equal to 3, we have verified. Can we compare K equal to 3 and K equal to 4 in the same? No.
Super, sir. You can, please. Beautiful. I wanted to talk about that. Perfect analysis, sir. Well, you can do what you do. Simply have to go to setup. Simply have to click on add new. Select the same IBK. Simply put here 4. Simply click on OK. Again add new. Select IBK. Select K equal to 6. Click on OK. You see, sir, you have the same IBK but different K values. This kind of analysis also you can do.
Thank you, sir.
Super. You can do that. In fact, you can go there, click on run, click on start. You see there are 0 errors. Go to analyze tab, click on experiment button, come down left side, perform and test. Sir, can you tell me what is better now? What is your observation, sir? For iris data set, regardless of the K value, regardless of the K value, the performance is not changing much.
Yeah.
The performance is not changing much. So for any people who have still not understood, look at this V symbol. Okay. And look at this 1 down in the left side. If it is a 1, it means it is performing better than baseline. Okay, but if you look at this 94, 95, 95, 96, not much of variation is there. Maybe since the last one is having 96.73, maybe I will take this as my model. For that, the K value is 6. Okay, so for that, I will go back to Explorer. Okay, select this KNN as 6, click on OK, and click on Start. You build your model, right? You build your model, right? Now, you should know how to save this model. Okay, you should know how to save this model. So all of you, please carefully understand. You see left side down in the result list. Right click on this. See, this is the latest one, right? 1417, 417 time. Right click here. Click on save model. So I'm selecting. I'm calling it as tree model. Don't call it as tree model. You will say IBK underscore 6. Remember, K value is 6, right? So IBK underscore 6 underscore model. Click on save. I have selected. I have saved it in desktop. Remember the location. Click on save. So you have saved your model. Okay. Once you saved your model, you can use this model to predict. You can use this model in future to predict. It's already 4:18. Shall we also see how to predict values? Shall we stop? क्या करेंगे? There is so much to talk. It is 4:20, right? Okay. Any problem here? Anyone was not understood how to save the model? No problem. Okay. So I don't see any. Right. So now please remember this. See, I'm closing my environment. Experimenter I'm removing. Okay. I'm going back to Explorer. See, I have saved my model. Close Explorer. Okay. You have to close Explorer. Now, before closing, what is my prediction? What is my prediction? See, what is the data set we are working on? The data set is iris, right? The data set is iris. So what I want you to do is, okay, you have to use your notepad. Where is notepad? This is my notepad. Okay, you have to open your data set. What is your data set? Iris, right? So I'll open my iris. It is in WEKA. It is in data. All files. I'll select iris. Open. You see, this is the file format for ARFF. So many things are there. Will not worry. How many rows are there in the data set? Anyone? Fast? 150, right? I don't need 150. See, I want to show how to predict values. Okay. I will. Iris setosa. Okay. Let me. There's no time, so I will delete all other rows. Only these rows. Don't touch this percentage symbol. Delete them. See how many rows I have? 3 rows, right? Now, what is the last column? Anybody? My class attribute, no?
Class.
Yeah, I am deliberately putting it as question mark. I am removing that and I am putting it as question mark. Okay. Now remember in WEKA, question mark means missing values. For WEKA, if it sees question mark, it thinks it as a missing value. Don't put as empty. Okay, empty is treated like a value. Right? Now save this file. Now you have to save it. Don't touch the original, by the way. I am changing the original here. I'm changing the original. I am not supposed to change the original. So I will assume that you would have made a copy of iris, and then you would have opened that copy, and then you would have deleted all rows except these 3 rows. and you put them as question marks. So I will save it as iris underscore predict. Don't change the extension, okay? I don't know whether this works or not. If it works well, otherwise we'll have to stop. Okay, so iris underscore predict. We don't know whether this works or not. Ideally, what you should do is you should go to Explorer only. Okay, and you should use a filter. We should use a resample filter. Where is the resample filter? There is a resample, right? We have seen that. Reorder, replace, paradise. Somewhere it is there. You have to use this resample to create two different parts of your data set. Okay. Ideally, remember 66% should be for training. The rest will be for testing. For creating a new data set with unknown class labels, use resample. Select the sample size as, let us say, 1%. Okay. Click on apply. You will get one row. So this you save. This you save as iris underscore predict. Then go there and change the class value to question mark. That should be the ideal way. Okay. Anybody who has a problem? How do you go? Which rows go in training, which not? There is no rule for that. You have to use resample. Simply directly split into two parts using with replacement or without replacement. It's your choice. At random. At random you have to do. Just make sure at least 60% of the values you have used for training. And one more point, in training dataset, you have to make sure all class labels are occurring. If all class labels are not occurring, the learning will not be correct. If the learning is not correct, then the prediction will not be correct. Because for those class values it has not seen or it has not got trained on, it cannot predict. Understood, sir? Patil sir or madam? Right. So I'm trying to wind up. Okay. We don't know whether it is works or not. What did we do? We opened our data in iris. We saved it as iris predict. Okay. Then you should see. Remember, we have saved our model. Okay. So close Explorer. Close Explorer. Again, click on Explorer. Okay. What should we open? You can open any file, because see, I'm telling you how to predict. For this, you can simply open iris only. So I'll open iris. Okay. Fine. So I've opened my iris file. Go to classify tab. Look at this supplied test set. Look at this supplied test set. Okay. Supplied test set. Click on set. Right. Then click on open file. What do we want to open? We want to open that file with unknown values, right? We want to predict that, Gada. So I will select iris predict. Okay. Make sure this class is selected here by default. Click on close. All of you have understood this? Any problem here? What did we do? We opened iris dataset. Okay, in pre-process tab. Then we went to classify tab. Okay, and then we have selected this supplied test set option. Clicked on set. Clicked on open file. Selected our predict file. Opened it. Okay. Opened it. Done. Now, what do we want to do? We want to use our model to predict the values. We want to use our model to predict the values, right? But so what is the first thing to be done? You see, you have to load your saved model. So right click here in the result list, click on load model, select the model which you have created previously. Okay. In this case, it is IB6 6 model. So my model is loaded. Any problem here? Anybody who has a problem? I'll close in 5 minutes. Please bear with me. Yes, sir. You can use WEKA for text data set. You can use for images. You can use for documents, text. Okay, images, videos. Only thing is you have to do pre-processing and convert your data set into rows and columns. That's it. Go to internet. You will see n number of tutorials which tells you how to do this. You can use text data set for WEKA, sir. Easy. Text mining using WEKA. Right. So we have done this. So we have loaded our model. Now you see, after loading this model, again right click, click on this re-evaluate model on current test set. Okay. Okay. Right click, re-evaluate model on current test set. Some problem has occurred, I told you. So we should not use that text pad. We should not use that text pad. But if you, after clicking on this re-evaluate model, you see here, you will get predictions. You will get predictions. Let me show you one file which I already have. Somewhere. Replace missing values model prediction, but I have stored somewhere. Okay. I don't remember where did I keep it. Delete row, missing values, experiment, iris model. Okay, let me. I don't know where did I keep. But have you understood the steps? If you click on right click on this and re-evaluate model, you will get your prediction here. Okay. It's 4:30. So we have breached our time. We have breached our time. So let me stop here abruptly. Before stopping, I just want you to see a paper. I have found out some people have used WEKA for their research. Okay. Right. There is a 2020 paper from some Chinese good university. You see this? This is from IEEE Access. This is from IEEE Access for latest 2020 paper. Okay. These guys have used WEKA and some other tool. They have they did a comparative analysis on breast cancer data. Okay, look for this paper in the internet. So many algorithms they have explained the same strategy. They will explain the data set. They will explain the algorithms. Then you see, then they will do some gimmicks. You will put all these graphs and these tables. Then they will do analysis. Okay. They will select the tool and they will do this all this sort of analysis. So much work they have done. This is, you see, comparative analysis of machine learning techniques. One of you tell me, how can you get this table? You will use experimenter in WEKA. Okay. You can use experimenter to get this table. Fine. And so much work they have done. They have did a lot of survey on breast cancer analysis. Okay. And they have given so many references. Why I am quoting this is because they have used WEKA also in their work. They have quoted WEKA also here. You see, WEKA. See, here they have used these algorithms. We have already seen this. Okay, WEKA, they have used other things also. So, tool, the data set, number of attributes, data types, pre-processing, okay, evaluation, validation technique, accuracy. Okay, you can do this kind of analysis for your data sets. Okay, so this is one latest paper I found out from IEEE Access. You can't download this. You may have to pay money for this. Okay, we don't know whether it is available for free or not. Okay, similarly, somebody did a comparative analysis on data analysis of wireless networks using classification techniques. They have used WEKA for this. Okay. Then see, these people they did a comparative study of classification techniques for some large scale data. This is from 2017. So this kind of simple analysis you can do for your own data set. Okay. So now you know, if you read that paper, you can do the same work on the same lines. You now know, you just have to understand explorer and you just have to understand experimenter. Use both of these, use appropriate filters, do your analysis on multiple algorithms on your data set. Okay. You can do a lot of beautiful descriptions you can do, and then you can do predictions also. Since there's no time, I am not showing you that prediction. Okay, so let me stop here. Thank you for bearing with me for so much of time. I'm sorry for crossing over the time. Thank you.
No, sir. Thank you very much, sir, for this very informative and detailed hands-on session. WEKA was really new to all of us. Though there was a time constraint, you have taken the utmost efforts to clear many multiple points and clear all doubts of the participant also. We will really like to have, sir, one more detailed session with you in near future. And
Great. Thank you so much, madam. Always willing. Yeah.
yeah, I request any participant would like to give a feedback or something like that. So you can unmute yourself and see. Link will be shared in the chat box, feedback link. But anybody wants to give any feedback, and they can unmute the mic and say.
Sorry, I had to be very fast because so much to talk and so little time. And I already took more than 40 minutes extra.
No, sir, but I think the participant got more benefit. Yeah.
Sir, good evening.
Very well.
Yes, sir.
Okay.
Good evening, shall I?
Yes, sir.
So, sir, actually I was using this WEKA previously without any guidance. Now I got an you have given me an eye-opener for this entire week of software. Thank you for your session, which was really an informative one. Thank you, sir.
Thank you, sir. Thank you. There's one more knowledge flow. If your data set is sequential, you can use knowledge flow to do your analysis. Yeah.
Thank you very much, sir. I would also like to thank you for a very lucid presentation and very thorough explanation. Also repeating it 2-3 times so that we get it thoroughly, step by step. And because I belong to the biology field, and I have just ventured into data science, and I'm just going step by step to understand more. And you showed us a paper on predicting breast cancer using machine learning using WEKA. That is an eye-opener because I never thought that they have already started using all these tools. So thank you so much for this. And like you said, it is yeah, I mean, even we can venture into this because I'm a pure microbiologist, but I'm sure I can venture into this. And you have been very, very simple with your explanation. Thank you very much, sir.
Thank you,
and
thank
if
you,
I would like to, thank you, sir. I would like to tell the organizers, if you really organize another session, please invite us to that. We would be very willing to join another detailed session. Thank you.
Sure, ma'am.
Yes, I want to also share my feedback, madam. Can I?
Yes, madam.
Yes, ma'am.
Yes, sir. Really, it was a good session. Because before this, I have never used WEKA, and this year I am teaching data mining subject, and there I want to use WEKA. So, really good session, sir. Thank you so much. And if possible, please organizers again arrange one more session of sir. Thank you, sir.
Thank you so much, madam. So delighted.
Yes, ma'am, surely. Yeah, the comments we can see in a call messages, all are very happy with the sir session. It was really a detailed session. I really thank you, sir, once again for your time and your guidance. And we really hope that we'll surely will have one more detailed session on WEKA near future with you.
Thank you so much, madam. Always ready. Thank you so much. Thank you, one and all.
Thank you. On this note, I say that today's session is over. The link is shared. Tomorrow's link will be the same. You can join tomorrow at 2 o'clock, 2 p.m. And we'll start with the session at 2 tomorrow. If you have any queries and doubts, you can WhatsApp us. Thank you all. So we conclude this for today. Thank you. Thank you, sir. Thank you all.
Thank you, ma'am, for allowing sir to extend the session so we could get additional info. Thank you.
Yeah,
Good day,
ma'am.
ma'am.
Thank you. Good day.